Okay, so now we've started the part 2 of modulus arithmetic. Part 2, modulus arithmetic. So here I have continuation on modular arithmetic. So in general, okay, two integers a and b. When I say a and b, like this, a and b. Okay, all right. So two integers a and b are said to be congruent modulo m, written as this: a congruent b modulus m. Okay, now what conditions satisfies this? When you say a and b are congruent, what condition satisfies this? Now the condition is that their difference must be an integer multiple of m. So if a and b are said to be congruent modulo of m, then a minus b must be an integer of multiple m, where the number m is referred to as the modulus of the congruence, where the what number m is referred to as the modulus of the congruence. I'm taking time to teach now, so that in my next video I'm going to show you these two examples. All right, then I'll also do more worked examples, and then we proceed. So let's take it again for the sake of clarity. Two integers a and b are said to be what? Congruent modulo m if their difference, that is a minus b, difference in mathematics is mine, right? A minus b is an integer multiple of m, where m is the what? Modulus of the congruence. Now, for example, look at this type of example. Look at this type of question. Show that the following pairs of numbers are equivalent in the moduli given. A, I have show that 577 and 46 are what? Equivalent in the moduli given. The modulus here is 9. Now in mod 9, prove to us that 577 and 46 are equal. Then the second example says, prove to us that 140 and 404 are equivalent in mode 6. We're going to take them one after the other. Solution. Now, the two numbers given are what? Let's go to the first example. They are what? 577 and 46. Okay. And the modulus is what? 9. Beautiful. So, I'm going to use two methods to approach this. The first one is what I did here. The second one is here. So, let's start with this first one. What's the first thing you need to do to show that 577 and 46 are equivalent in mode 9? What's the first thing you're expected to do? 1. Express as product and sum. Let me explain to you what I mean by that. Remember, the modulus given is what? 9. Alright? So what you do is take the first number, 577. Look for a number that when you multiply it by the modulus given, you will get a number very, very close to this, or a number equal to this. Either close to it or equal to it. So when I tried using the multiplication table, I discovered that 64 is the closest. Now for the second number, I'll show you. Just hold on, okay? For the second number, 46. Remember the modulus is 9. Look for a number that when you multiply by this modulus 9, you're going to get a number very, very close. Now, let me now show you what happened there. Now, while trying the multiples of 9, I discovered that 64 multiplied by 9 is 576. So you can see that 576 is the closest number to 577. So I brought down the remainder here. Then while I was trying the multiples of 9 again, I noticed that when I got to 9 times 5, when I got to 9 times 5, I got 45. And 45 is the closest number to what? To 46. So I wrote it down, then I brought down the remainder. So if you now observe, you will see that now that I've gotten the closest multiples, you observe clearly here that both numbers, that is 577 and 46, share remainder 1. That means they both have remainder 1. Now, if you take their difference, 576 and 577, the difference is 1. If you take this one, 46 and 45, the difference is 1. Now, when both of them share such difference, it is a hint that you're getting very close to the answer. Okay? Now, what do you now do? Remember the condition. If a minus b is an integer multiple, what is a? 577. What is b? 46. Let's take their difference. Okay, let's take that difference. 577 minus 46. So I have 7 minus 6 to give us 1, 7 minus 4 to give us 3, and then you bring down 5. Now, if you check your multiplication table, you will notice that 531 is a multiple of 9. Check your multiplication table to confirm. Because of the length of this video, let me quickly go to the second example. Remember, we were given 2 examples. The first one we've treated, second one 140 and 404. I believe at the end of this second one, you'll be able to pick what I'm trying to say. Now, let's go to the second one because of time. Now, 140 and 404 show that both of them are what? Equivalent. Now, the mode given is 6. So, look at this. I believe this one will be very, very fast for you. Now, workings. I had to use a different method. If you notice, that first one is very long. So, I took 140 divided by the mode. I took 404 divided by the mode. Now, when you divide 140 by 6, you're going to get 23 remaining 2. Also here, you're going to get 67 remaining 2. Do you get? Now, you will now notice that both are what? Congruent, because they have same modular equivalent 2, and their difference is a multiple of 6. What is their difference? Now, when I took the difference between this and this, I got this. The difference between 140 and 404 is 264. Then I went to my multiplication table and started checking the multiples of 6, and I noticed that 264 is a multiple of 6, which satisfies this condition that says, well, the difference must be an integer multiple of m. M here is what? The modulus. So the modulus here is 6. So to summarize this video, because I have to end this video now, the modulus here is 9. Okay? And when I got their difference, here when I solve, I got 531, showing that 9, when you start taking multiples of 9, you're going to get that. Then the second one, when I did it, I got 264, showing that is a multiple of 6 in mode. So let us now try these work. In my next video, I want to work all these out, state whether the following pairs of numbers are equivalent in the modular given. I'm going to work all of them out. Then we'll be able to see clearly what we mean by equivalence.